Good evening. My name is Fakbojuwo Oluwatoba David, aka Prof.T. Tonight, I'm teaching electric circuits. What is an electric circuit? An electric circuit is a device that gives energy to charged particles and its constituents, like battery, that charge phones, like and other devices. And that is that we have components of electric circuits that makes it to work like a device. We have the resistors, we have the voltmeter, we have the ammeter, we have the wires, you could have a bulb, we have a switch, and so on. We have the rheostat, and so on, like that. So now, I want us to teach a question on electric circuit tonight. But remember, electric circuit is a topic from grade 10, grade 11, and grade 12. In grade 10, they teach how to solve an effective resistance, which means looking for the effective resistance of a particular electric circuit. Now, in grade 11 is when now you go to how to find a voltage, to find the current, and all that, and it's very important to know the definitions of all this voltage, current, electric circuit itself, because those are 3 marks. We call it the 2 marks. And also Ohm's law is very important. Ohm's law is very important. You must be able to divide Ohm's law from grade 11 and grade 12. These are matric questions from last year that we are solving now. Matric questions 2023 November December. So you remember in grade 11 is going to be V equals to IR, actually from grade 10 anyway. But now we're solving question using that equation. But when you are looking for any of those variables, voltage is always on top. But when you are looking for voltage, is IR that will give you voltage. Okay, cool. Now to grade 12, the voltage becomes the EMF, and the EMF is equal to capital R into bracket big R plus small r. Now, EMF is another package. EMF is when you buy a battery, the voltage of the battery is the EMF. But once the battery is inactive, it's not going to show the exact voltage that you saw on the battery, because there is a small resistance that the battery also uses for itself. That is the small r. So in this question, we are going to go closer. Let's go to the question. So now we have this question which says the electric circuit diagram below shows a battery with an EMF of 12 volts and an internal resistance of 0.5 ohms connected to 3 resistors, a light bulb, a switch, and an ammeter connecting wires. The ammeter and the connecting wires are negligible resistors. This is the electric circuit, as you can see. And in this electric circuit, it's so simple. It's one of the simplest electric circuits I've ever solved anyway. So now the first question says, state Ohm's law in words. You must be able to state Ohm's law. You remember Ohm's law states that the current across the 2-point charges is directly proportional to the voltage across the 2-point charges at a constant temperature. That is Ohm's law. That is the 2 marks marked. So they said switch S is initially closed. Calculate the total external resistance of the circuit. If you look at this circuit very well, we have external resistance, which will serve for your big R in this formula, EMF. So in this formula, your internal resistance is the small r, external resistance is the big R, the EMF itself, and you have the I, which stands for the current. Now, to solve this question, you must know that the current of this electric circuit from the internal resistors is in series with the external resistors. What I mean is the internal resistors is in series with the external resistors in series. So they are going to use the same current. That's the secret that you must understand. That's the trick that you must be able to overcome. So they said, the question 2 said, total resistance, calculate the total resistance, total resistance of the circuit. If you can see, resistance are arranged in 2 ways. Series and parallel. This is a parallel arrangement of resistance. Why this is a series? Because a series means the current only have one pathway. So this is only one pathway. Here, the current will enter here. When it gets here, it's going to go here or go here. That is 2 pathway. Now, they want to effect resistance. We need to calculate the resistance. To calculate the effective resistance, we need to say R series, which was RS plus RS2, RS1 plus RS2. We give us R3. Then we need to look for RP, which will give us R1 over RP1 plus 1 over RP2. Pardon my board. So I'm using a permanent marker, so I could not easily remove others that's been here, but I'm just using this to explain to us. Anyway, we're going to follow it up like that. So now we are here now. They said external resistance, so we need to look for which one is in series. This one is in series. This is in parallel with this. This is not in series. This is in series with this. These two and these two, they are in series. This one, because there's only one pathway that goes from here to here. So these two are in series with this. So the only one in parallel is this one. And these are the one in series. This is one in series. This one plus this one in series will give us. So let's do it. So let's come here. So what are we going to do? We are going to say R1. Are you with me? R1 over R2. Let's do this one, which is R in parallel. So we have 1 over, okay, sorry, I can't write on this board. Let me continue in the next class. That I've worked out my. So let me explain to you. That's how to get it anyway. So how to get it is to look for the R parallel. So after we have looked for R parallel of these two using this formula, then we are going to add it to this one because they are in series. Then you are going to add it to this one. Because now these two and this one, to this one is in series. We are going to add it to this one. So that's how we are going to get it. That's how we are going to get it. We are going to add this one to these two that we get. Then we are going to have effective resistance, which means we are going to add 15. Because this is going to be 1 over RP. We are going to have 15 to this one. Then we're going to get it. Then this one, 8,22, reading on the ammeter. They want us to find the current. So let's go and find the current in the next class. Thank you.